Okay, calculus. Now, we saw what happens if you have 3 variables and 1 constraint. Went pretty straightforward. However, what we haven't seen yet is multiple constraints, and you can have multiple constraints. So what we're going to have to do is, in addition to lambda, we're going to introduce a second extra variable to deal with the second constraint, a nice mu. The strategy is still the same though. So let the t of x, y, z equal 20 plus 2x plus 2y plus z squared represent the temperature at each point on a sphere. X squared plus y squared plus z squared equals 11. Find the extreme temperatures formed by intersection of the plane x plus y plus z equals 3 and the sphere. Okay, so we have these two constraints and we have a temperature function. It says the extremes, so we need to maximize and minimize. So we're expecting that there's going to be multiple different values here. But again, we're going to take our derivatives. T sub x is 2. T sub y, y's partial derivative is also 2. T sub z is 2z. Let's take our partials. To g of x is 2x, and again it has to be multiplied by lambda. G of y and g of z are the exact same. 2y times lambda and 2z times lambda. Now we have a third function we call h of x, h of y, and h of z. That's our linear function down here. Thankfully the derivatives for all these is 1, but it has to be times a new variable. Now, what's going to happen here is instead of these two being equal to each other, and now this, our constraint, or our max-min function, has to be compared to the sum of these two gradients, which means 2 has got to equal 2x times lambda plus 1 times mu. 2 for y has got to equal 2y times lambda plus 1 mu, and 2z has got to equal 2z times lambda plus mu. Now you're thinking to yourself, there are 5 variables in this equation, and that's not fun for me when I have 3 equations. So we're going to have to be clever here in order to solve this, and it has to do with looking at these 2 equations. One of the things we like to do in systems of equations, if we can, is eliminate a variable. So what do you notice happens if I subtract the first 2 equations? 2 minus 2 is 0, so we get 2x lambda minus 2y lambda, mu minus mu, still 0. These both have a 2 and a lambda, so when it's equal to 0, thankfully I can factor 2 lambda times x minus y. So if 2 things multiply to 0, we know one of them has to be equal to 0, so either lambda is 0 or x minus y is 0, which means x equals y. So we've got 2 cases here, and we're going to have to explore each case because they could both produce some outcomes. So let's first do the easy one, if lambda is 0. If lambda is 0, it makes all of our functions very easy because it's going to kill this 2x, 2y, and 2z. So we get 2 equals mu here, 2 equals mu here, that's a little redundant, and 2z equals mu here. Now if 2z is mu, that means 2z is equal to 2, which means z is 1. Now if we look at our constraint functions, x squared plus y squared plus z squared equals 11, and x plus y plus z equals 3. Removing z and putting 1 in its place, we'll get x squared plus y squared plus 1 squared is 11, and x plus y plus 1 equals 3. So that means x squared plus y squared is 10, and x plus y is 2. Using substitution, say y is 2 minus x and sub it in. So x squared plus 2 minus x squared equals 10. So x squared plus 4 minus 4x plus x squared equals 10. If I move everything to one side, that would be 2x squared minus 4x. 4 minus 10 is minus 6 equals 0. Divide by 2. X squared minus 2x minus 3 equals 0. So either x minus 3 or x minus 1, or x, minus 3 and plus 1 equals 0. So either x is 3 or x is negative 1. To go with the z equaling 1. So if x is 3, we know that y is 2 minus x. That means y is 2 minus 3. Or y is 2 minus negative 1. So that means y would be negative 1 and y would be 3. So that means it gives us 2 points. Either x is 3, y is negative 1, z is 1, or x is negative 1, y is 3, z is 1. Okay, so those two we'll check in a bit. Now let's do the more annoying one, x equals y. What does that do to our equations? Again, we look at our constraints. It'll be x squared plus z squared equals 11. X plus z equals 3. So still two equations, two variables. That's 2x squared plus z squared equals 11. 2x plus z equals 3. Z is 3 minus 2x. Substitute it in. 2x squared plus 3 minus 2x squared equals 11. It's 2x squared plus 9 minus 12x plus 4x squared is 11. Move everything to one side. 6x squared minus 12x. Looks like minus 2 equals 0. So 3x squared minus 6x minus 1 equals 0. Unfortunately, that doesn't have a factorable solution, so we need to use the quadratic formula. X is, 6 plus or minus square root of b squared, so 6 squared, 36, minus 4ac, that's minus 4 times 3 times negative 1, so that's plus 12, all over, it looks like 6. 6 plus or minus the square root of 48 over 6, which is 6 plus or minus 2 square roots of 12 over 6, or 3 plus or minus the square root of 12 over 3. You can pull something out, so it's 3 plus or minus 2 square roots of 3 all over 3. And we know that x equals y, so that's for both x and y. Now the only thing that we don't know, so that means either x is 3 plus 2 square roots of 3, or it's 3 minus, and y corresponds respectively. So we've got 3 plus 2 square roots of 3 over 3, 3 plus 2 square roots of 3 over 3. We need to find what z is when it goes with it. 3 minus. Now you can calculate it by plugging this back in. I'm going to just go ahead and tell you what z is respectively here. It ends up being 1 minus 4 square roots of 3, I believe. Here, 1 minus 4 square roots of 3 over all over 3, or 3 minus. Okay, so we're not done. We need to find the max and min by plugging these all in. If I plug in the two over here, 3, negative 1, 1, and negative 1, 3, 1 to my constraint function, I end up getting t of 3, negative 1, 1, and t of negative 1, 3, 1, both equal 25. If I plug these two terrible things in, it looks like plugging both these in, you end up getting about 30.33. I would round these to decimals and just plug them in using a calculator. So does that tell you that the max is about 30.33 from these? It's one of the critical values, and the min is 25. And that is all for 1310, which is the last section, so there will be a test on chapter 13, and I'll send out more information on Canvas.